Welcome everyone. I am Ujjwal Pal. Today we will solve a LeetCode problem step by step. The problem number is 1310, which is XOR queries of a Subarray. Let's see the problem statement. You are given an array ARR of positive integers. You are also given the array queries where queries I will be left and right. For each query I, compute the XOR of elements from left to right, that is ARR left XOR ARR left plus 1 and up to ARR of right. Return an array answer where answer I is the answer of ith query. And this is one examples, and the constraints are the length of ARR and queries will be up to 3 into 10 to the power 4. Each element of ARR will be up to 10 to the power 9. Queries length will be 2, and left and right, which will be present in the query I, that will be from 0 to less than array dot length. So we have to calculate the like XOR of the given range, which is left to right. We both are inclusive. From left to right, we have to calculate the XOR. And the XOR has one thing, like if you do the XOR of same values, it will give you 0. So we will use that. So first we will create an array of like values, like XOR values from left 0 to that element. Like for each index we will find the XOR value from 0 to that element. Like for 0 it will be XOR of 0, for 1 it will be XOR of 0 and 1, for index 2 it will be XOR of 0 1 2, like this. From left to right we will go, and each index will contain the XOR of 0 to up to that element XOR. And whenever we have to find the query from left to right, first we will take the value of XOR value of right, because we already have calculated, and we will again XOR that with the value of left minus 1. That means from 0 to left minus 1 will be counted two times. In up to when we are counting right, that means it will take the XOR of 0 to right, up to right, and we are taking also XOR of up to left minus 1. So it will take the XOR of 0 to left minus 1. So the 0 to left minus is coming two times, because right always be greater than left. So left 0 to left minus 1, that value will is coming two times. So it will become 0, and only the value will be remaining will be from left to right, the XOR value. And we have to put that in an array, and we need to return that. So first we will create, let's say the size of ARR is n ARR dot size. Now we have to create a vector of int, let's say it is VC. The size will be n. It will contain all the XOR values we from left to right, from 0th index to up to that index. So let's loop over I equal to 0, I less than n, I plus plus. The VC of I will be, we need the XOR value from 0 to that element. To do that, we will use another value, which is, let's say, current. Initially we need to keep it 0, because we know after first value, like whenever we do XOR with 0, it will give that value. So initial value will be 0. Now first we need to do the XOR. Current will be XOR equal to the current element, which is ARR of I. Now VC of I will be current. That's it. Now we have all the XORs from left to right, and each index will contain the XOR value from 0 to that index. Now we need the answer vector, or which we have to return. So that length will be m, which is same as the queries dot size. Now let's say vector bool answer of size m. Now let's say query in I equal to 0, I less than m, I plus plus. We have the left is equal to queries of I 0 because the size of each query will be 2, that means 0 and 1. So 0 that 0 index contains the left side and right side is equal to queries of I1. Now first we need to find the value XOR value of right from 0 to right index. To do that, let's say val equal to VC of R. Now we got the value up to R. Now we need to like XOR it with the value of left minus 1. And if we are finding left minus 1, we need to check that if left is not equal to 0. Because if left is 0, that means left minus 1 will not exist. So if left means L is greater than 0, then only we will do value XOR equal to VC of L minus 1. Okay. Now we have to put the value in answer of I. Now return answer. That's it. Let's see will it work or not. It is accepted. Let's submit it. So it is accepted. Let me discuss the time and space complexities of this algorithm. So the time complexity for this first for loop is big of n, where n is the size or length of the ARR. And for this second for loop is big of m, where m is the length of queries. So overall time complexity will be big of n plus m. And space complexity, first we are creating a vector of size n, where n is the length of error, and we are also creating another vector of size m, where m is the size of queries. So you can say the space complexity is also big of n plus m. So thanks for watching. If you want to check out the code, you will find it in the description box below. So that's it for today. See you in the next video.